Welcome to Statistics. My name is Dr. Twane. In continuation of our series on reliability analysis, our emphasis today is on the Cronbach Alpha. Please, if you have not subscribed to our channel, do well to click that subscription button. Also click on like. Now, the Cronbach Alpha is a measure of reliability. We use the Cronbach Alpha to measure the internal consistency of a measurement scale. Now, a measurement scale has a set of questionnaire items. It may be 4, 5, 6 that are used to measure an underlying concept. Now, a measurement scale may have, say, a kind of Likert scale that has a close-ended multiple choice questions. For instance, you have options like, say, strongly disagree, neutral, undecided, agree, and strongly agree. Now, these are coded as 1, 2, 3, 4, and 5. It may also be in the form of, say, very low extent, moderate extent, high extent, and very high extent. This is also coded as 1, 2, 3, 4, and 5. So these options provide the data with which we compute our Cronbach Alpha. If our Cronbach Alpha values computed falls within, let's say, 0 to 0.49, then our conclusion is that the scale is what? Unacceptable. If we compute our Cronbach Alpha and we have values between 0.5 to 0.59, then our conclusion is that the scale is poor. If we compute our Cronbach Alpha and we have values between 0.6 to 0.69, then our conclusion is that the scale is questionable. And now when the values of our Cronbach Alpha is between 0.7 to 0.79, our conclusion is that the measurement scale is what? Acceptable. Now, if the measurement scale is between 0.8 to 0.89, then we conclude that the measurement scale is good. And for values between 0.9 to 1, then we conclude that the scale is excellent. Now, having done that, we compute the coefficient of our Cronbach Alpha using the formula that our R sub alpha is equal to, we have K all over K minus 1, all of that into 1 minus summation of Si square, where our I goes from 1 to K all over S square. An attempt to measure the preference for fast food outlets in Port Harcourt. A questionnaire having 5 questions for constructs was administered to 8 respondents for a pilot test. The coded responses are shown below. Now you are required to compute the Cronbach Alpha and interpret the results. Now, this measurement scale is used to measure preference. Preference is considered in terms of ambience of the fast food outlets, the taste of the food prepared, the hygiene of the environment, the location of the fast food outlet, and also the price regime. Now, if you choose very poor, then that will be coded as 1. If you choose poor, it will be coded as 2. Moderate is coded as 3. Good is coded as 4. And very good is coded as 5. Now, this is what is used to obtain this data we are to present now. So these are responses on the questionnaire items. We had this to measure the preference of the fast food outlets. So the first item was ambience. So these are responses on ambience. The second item was on taste. These are responses on taste. The third was on hygiene. These are responses on hygiene. And then we have also on price and the others. So if we have this as the responses, now we are expected to compute the Cronbach alpha. So what we do is, firstly, we create a column, call it y. And what's that y? The summation of all the items. Because we are expected to compute the variance of each item and the variance on the sum of items. So for summation of items, we have 4, 4, 4, 12 plus 6 will be 18. Also 4, 4, 4 plus 6 will also be 18. And then we have 5, 5, 5, 15 plus 8 will be 23. And then we have 4, 4, 4, that's 12 plus 10 will be 22. And then we have 4, 4, 8, 10, and this will be 13. We have 5, 5, 10, and 10 will be 20. And then we have 4, 4, 4, 12, 14, and 19. And then we have 1, 2, 3, 4. As 8 plus this is 11. Okay? So now, note that because of computation of the variances, we are going to compute the mean of each of the items. And so for us to compute the mean, definitely we need the sum of the items. So let's put this as a summation. So if we sum the first item, 1, 2, 3, 4, 5. So 4 is appearing 5 times, that will be 20, plus 5 and 5 is 10. That's 30, 32. So this is 1, 2, 3, 4, 5. That's also 20. So this will be 26, 28. We have 28. This is 1, 2, 3, 4. That's 16. So this is 26 and 30. Okay. So for us to compute the arithmetic mean, we'll say that our Q1 bar will be equal to summation of Q1 all over N1. That will be equal to the sum of Q1 N1 is over 8. Okay. Now the next will be our Q2 bar will be equal to summation of Q2 all over N2. And that will be, the sum of Q2 is 28. So we have 28 all over 8. That will be 3.5. So the next is Q3 bar, which will be summation of Q3 all over N3. And our sum of Q3 is 30. So we have 30 all over 8. And that will be 3.75. So we have Q4, which is summation of Q4 all over N4. And that will be equal to, we'll have 22 all over 8, which will be equal to 2.75. Okay, then our Q5 will be equal to summation of Q5 all over N5. And that's equal to 32 Our sum of Q5 is 32. So 32 all over 8. That's equal to what? 4. Then the next thing will be our y bar. So y bar will be sum of y all over. That is equal to our sum of y is 144. Over our n is 8. So 144 over 8 is 18. Okay, having computed the mean of each of the items, now we are going to compute, we'll first create a column and call it x1. Our x1 will be q1 minus q1 bar. This is q1. Our q1 bar is 4. So 4 minus 4 will be 0. 4 minus 4, 0. 5 minus 4, 1. 4 minus 4, 0. 4 minus 4, 0. Okay? 5 minus 4, 1. 4 minus 4, 0. 2 minus 4, minus 2. So if we sum this, it will be equal to 0. Now the next is to create another column and call it x2. Now x2 will be our q2 minus q2 bar. What is our q2 for? What's q2 bar? q2 bar is 3.5. So 4 minus 3.5 will be 0.5. Okay, 4 minus 2.5 will also be 0.5. 5 minus 2.5 will be 1.5. 4 minus 3.5 will be 0.5. 1 minus 3.5 will be minus 2.5. 4 minus 3.5 is 0.5. So the top item, so our x3 would be q3 minus q3 bar. Our q3 is 4. q3 bar is 3.75. So 3.75, 4 minus 3.75, 0.25. So this is also 0.25. This is 0.25. So we have 5 minus 3.75, 1.25. So we also have Q4, and the mean of Q4 is 2.75. So we'll have our X4 as Q4 minus Q4 bar. Okay, so our Q4 here is 3. So 3 minus 2.75, 0.25. Then this is also 0.25. 4 minus 2.75, 1.25. This is also 1.25. Then 2 minus 2.75, minus 0.75, minus 0.75. And then here we also have minus 0.75. Our x5 is q5 minus q5 bar. So our q5 is 3, q5 bar is 4. 3 minus 4 minus 1. 3 minus 4 minus 1. 5 minus 4, 1. 5 minus 4, 1. 4 minus 4, 0. 5 minus 4, 1. 4 minus 4, 0. 3 minus 4, minus 1. Okay, so if you sum that, it will be 0 also. The sum of this will be 0. If you sum this, it will be 0. Okay, so now the last one on this is small y, which is going to be our capital Y minus capital Y bar. Our capital Y bar is 18, and our capital Y here is 18. So 18 minus 18 is 0. 18 minus 18, 0. 23 minus 18 is 5. 22 minus 18 is 4. 13 minus 18 is minus 5. 20 minus 18 is 2. 19 minus 18 is 1. 11 minus 18 is minus 7. From that, it will also be 0. Okay, now having done that, the next will be, because we want to compute the variance, and we know that computing variance will say S1 square is the variance of the first item, and that will be summation of x1 square all over n1 minus 1. So we are going to create a column and call it x1 square, which will be the square of this particular item. And the square of that, we have 0 square will be 0, 0 square will be 0, 1 square will be 1, 0 square 0, 0 square 0, 1 square 1, 0 square 0, minus 2 square 4. So if we sum that, 1 plus 1, 2 plus 4, 6. Now, again, we also need the variance of the second item, call it S2 square, which will be summation of x2 square all over n2 minus 1. So we are going to create another column and call it x2 square. So also we will do for x3 square, x4 square, x5 square, and then 4y square. For our x2 square, so 0.5 square will be 0.25. 0.5 square will also be 0.25. 1.5 will be 2.25. 0.5, 0.25. 2.5 minus 2.5 times minus 2.5. 6.25. 0.5 square. 0.25. 0.5 square, 0.2. So if we sum that x square, it will give us 12. Now for x3, 0.25 square, 0.0625. 0, that's the square of this. This is also 0.065. 0.065. 1.25 square, 1.5625. So if we sum that, 9.5. Okay. So then for 4, this is also x4 square will be 0.2, 0.0625. So to compute the variance of the first item, the summation of x1 square all over n1 minus 1. So the sum of x1 square is 6. So we'll have 6 all over. N1 is 8 minus 1. So we'll have 6 all over 7. And 6 over 7 is 0.8571. Okay? So the variance of the second item will be summation of x2 square. Summation of x2 square is equal to 12 all over. N2 is 8. 8 minus 1 is 7. So 12 over 7 is equal to 1.7143. So our S3 square will be equal to variance of the third item. And that's summation of x3 square all over n3 minus 1. So the sum of x3 square is 9.5. So we have 9.5 5 all over 8 minus 1 is 7. So 9.5 over 7 is equal to 1.3571. So we have a S4 square will be equal to, that will be summation of X4 square all over N4 minus 1. Hope you're able to see that. So that will be equal to summation of N4, summation of X4 square. Summation of X4 square, 5.5. So we have 5.5 all over 8 minus 1, which is 7. 5.5 over 7 is equal to 0.7851. Okay, so you have S5 square, which will be summation of X5 square all over N5 minus 1. So sum of X5 is 6 all over 8 minus 1 is 7. That's 0.8571. Our solution of SI square will be equal to the sum of all the variances we have computed for each item. So that will be, the first one is 0. We have 8571 plus 1.7143 plus 1.3571 plus 0.7857 plus 0.8571, which will be equal to 5.5713. Okay, now the next thing to compute will be the variance of the sum of items. Remember that the sum of items is y. Now when we deviated that to get this a small y, and then when we square that we have this. So that will be summation of a small y square all over n minus 1, which will be the sum of that is 120 over 8 minus 1 is 7. So 120 over 7, 120 divided by 7 is 17.142. Okay, so the next thing will be to compute our Cronbach alpha. So we have Cronbach alpha is equal to, we have k as we gave initially, k all over k minus 1, all of that into 1 minus summation of our SI square all over S square. I already explained to you that your k is number of items. In this case, we have 5 items. Question 1, question 2, question 3, question 4, and question 5. So, which means that our k will be 5 all over k minus 1 will be 5 minus 1. All of that times 1 minus summation of SI square. We already have the summation of our SI square as 5.5713 all over our S square, which is the variance of the sum of items. We have it as 17.1429. So this will be equal to 5 all over 5 minus 1 is 4. Then we have 1. Now 5.5713 divided by 17.1429 will be equal to 0.3324 approximately 325. Okay, so if we say 1 minus 0.1 minus 0.3250 would be 1 minus, so it will be 0.675. So 0.675 times 5 equal to 675 times 5, 3.375. All of that over 4 equal to 0.840 844, approximately 0.844. So our Cronbach alpha computed is 0.844. Now, if you look at the information we gave at the initial time, we said that if you calculate your Cronbach alpha as values between 0 and 0.49, then we conclude that the scale is unacceptable. If the value is 0.5 to 0.59, we conclude that the scale is 4. If the value is 0.6 to 0.69, we conclude that the scale is questionable. But from 0.7, we say that the scale is acceptable. Now, when you have 0.8 to 0.89, we say the scale is good. And what we have computed there is between that range, 0.8 to 0.8. That's why we have this 0.844. So we are going to conclude that the scale which we have used in measuring our preference for fast food outlet in Port Harcourt is actually good. Thank you very much and God bless you. Please, if you have not subscribed to our channel, do well to subscribe. Please like our videos. Share our video with your friends and colleagues. God bless you.